Hello everyone, welcome to my channel. If you are new to this channel or you haven't yet subscribed, your support in terms of subscription, comments and sharing of my videos with your friends is much appreciated. Let's get into the video. Now in this video we are to integrate the square root of x cubed minus 1 all over x dx. Now how do we approach this? Well, it looks very intimidating, but with spatial approach, u-substitution advanced case, you'll see how this integral simplifies so quickly. So we have the integral of x cubed minus 1, and we're taking square root of that, divided by x dx, like so. Now, like I said, we're going to remember this square root in the numerator, so we're going to let u squared be equal to x cubed minus 1. And the first equation we're going to obtain from this equation is to take the positive square root on both sides. So the positive square root of u squared should be equal to the positive square root of x cubed minus 1. And if you agree with me on the left hand side, you can quickly see that this cancels that. So what we have on the left is basically u being equal to the positive square root of x cubed minus 1. Now this is one of the first equations we're going to need towards the end. Allow me to put this in a rectangular box, because we're going to need this at the end. Right, now this is the first equation we obtained from this equation. The second equation we're going to obtain from this equation is by first of all rewriting. So I'm going to rewrite this equation to x cubed minus 1 being equal to u squared. And so from here I'm going to add 1 on both sides. What I get on the left, it's going to be x cubed. On the right, you'll agree with me that it will be u squared plus 1. Now this is x cubed being equal to u squared plus 1, and I have to take cube root on both sides to solve for x. So taking cube root on both sides, what we have is cube root of x cubed. The answer will be equal to cube root of u squared plus 1. Now again on the left, if you check, this cancels that, and what do we have on the left hand side? We have x on the left hand side, x being equal to, now watch how I'm going to write the right hand side. The right hand side, I'm going to write it as u squared plus 1 to the power 1 over 3. Remember, that's cube root. Right, this is another equation that I'm going to have to put in a rectangular box. We're going to need it at a later stage. What I need to do next is to square both sides. You say, why are we squaring? Because if you check this one here, x cubed, if you differentiate that, which we're going to do from this equation here, we obtain 3x squared from there. So we will need x squared here in order to get rid of u totally. I mean, get rid of x totally. All right, now moving on to the next page, which I'm going to call page 2. Page 2. Here we go. Remember now, let me put these papers in order. And let me move this one down. All right. Now we have to square both sides there. Now squaring both sides, if you agree with me, we're going to have x squared. The answer must be equal to u squared plus 1, which is to the power 1 over 3. We have to square this. Please make sure you see that this is 1 over 3. Right, now what do we get on the left hand side? We get x squared. On the right hand side, we're going to get u squared plus 1 all to the power 2 over 3, because we have 1/3 times 2 is 2/3. Now, this is another important equation we're going to need. Like I said, let me put it in a rectangular box as well. Finally, the last equation we're going to obtain from this equation here is to differentiate both sides with respect to x. Now, you remember we have u squared here, so we have to use chain rule there. As follows, let me just bring it down here. So we are talking now about u squared being equal to x cubed minus 1, and I'm saying derivative with respect to x of u squared must be equal to derivative with respect to x of x cubed minus 1. On the left, like I said, we're going to use chain rule. So what do we get on the left? So what we get on the left is going to be 2, remember, u, 2 minus 1 is 1, and then we're going to say du dx. What is this equal to? Well, on the right hand side, again, we're going to use power rule. Remember, there's a power of 3 there. Using power rule, we have 3x squared. Multiply the power and reduce power by 1. Derivative of minus 1 with respect to x is 0 because it's a constant. Now, fantastic. So what are we going to do now? You see the x squared coming up? That's why we needed it here. So next, we have to multiply both sides by dx as follows. So now we have on the left 2u du. On the right, we're going to have 3x squared dx. Now I have to solve for dx. Why? Because over here, I have dx there. So we have to get rid of that. Remember, the denominator is taken care of by this expression here. The numerator is taken care of by that expression there. And we are left with dx, which we must get rid from here. So making dx subject formula here, isolating dx on the right hand side, we're going to have on the left 2u du all over 3x squared, and then on the right we have dx. But like I said, x squared must go. That's why we needed this expression here. So now the left hand side transforms as follows. I'm now moving on to the next page, which is going to be page 3. I'm moving to the next page, which is going to be page 3. On page 3, what do we have? This is page 3. On page 3 now, what we have is the following. Remember this part here? I said the x squared must go. So what we have now is 2u du all over. In the denominator, we're going to have 3 open brackets. In the place of x squared, I have to put this expression here, u squared plus 1 all to the power 2/3. So I have u squared plus 1 all to the power 2/3. And on the right hand side, what do I have? I have dx. There it is, dx. This is equal to dx. Fantastic. Now the integral can be transformed totally. Let's get back to our integral. Here is the integral. The numerator is taken care of by that expression. So I'm going to have, therefore, let me copy the integral again. The integral of the square root of x cubed minus 1 all over x dx changes as follows. It will be the integral of, in the numerator, I'm going to have square root of u squared. Remember, that expression is u squared, as you can see over here. There's u squared equals x cubed minus 1. So we have it there. All over, in the denominator, we have x. Remember, there is x in the denominator. There it is. And what is the expression for x? It is u squared plus 1 all to the power 1 over 3. So I'm going to have here u squared plus 1 all to the power 1 over 3. And then multiply by dx. What is dx? Here is the expression. So it's 2u du all over 3 open brackets u squared plus 1 all to the power 2/3. All to the power 2/3. 2 over 3. Like that. Right. Now notice that 2 over 3 is a fraction and is a constant. It can be taken out of the integral. So we put it outside. So what we have now is the following. We have 2 over 3 times the integral of, notice something here, this cancels that. And so what I have in the numerator here is just u. In the denominator, I have u squared plus 1 all to the power 1 over 3. And then we have times. Remember the 2 and the 3 are outside. Now I have only there u du all over u squared plus 1 all to the power 2/3. All to the power 2/3. Fantastic. There is a third here. And there is a 2/3 there. Now, laws of exponents. I want to remind you something. Laws of exponents. Remember that if you have x to the power n times x to the power m, the answer is x to the power n plus m. Product, we add powers as long as the bases are the same. So if you check this one here, this base is the same as that base. So we're going to have to add the powers. So what is 1/3 plus 2/3? The answer is 1. So this integral then changes as follows. We have 2/3 outside times the integral of u times u is u squared all over, in the denominator we're just going to have u squared plus 1, and then we have du, because remember this and that will have a power of 1. So this is what we have eventually. Look at how simple that integral looks now. All right, moving forward, I'm going to perform a little trick on this one as follows. I'm going to perform a little trick on this. I want you to watch very carefully. Now, the trick I'm going to perform on that one is to introduce a special 0 in the numerator. So what we have now is, and this is supposed to be page 4. I'm going to introduce the special 0 in the numerator, 2 over 3 outside. Watch this. U squared plus 1 minus 1. There is your special 0 right there. All over u squared plus 1, and we're saying du. I was saying your special 0. Let me just circle it. There is your special 0. So I haven't changed the integral at all. But I'm going to use term-wise division now in the numerator, in the integrand, as follows. So we have 2/3 outside times the integral. Allow me to use square brackets here now. I have u squared plus 1 all over u squared plus 1. And then there's a minus here, so I'm going to have minus 1 over u squared plus 1. And then I'm going to have du outside, like so. Right, now moving forward, you can see that this is 1 here. So basically, I now have 2 over 3 times the integral of 1 minus 1 over u squared plus 1, and then we have du. Now I have to distribute 2/3 and du and the integral, and what I obtain is the following. 2 over 3 times the integral of 1 du minus 2 over 3 times the integral of 1 over u squared plus 1 du. Nice. Now, watch something here. Simple integrals to evaluate these two. What is this one here? Well, what we have here is 2/3 u, because the integral of 1 with respect to u is actually u. Let me just explain something here. If you look at 1, we can write 1 as the integral of 1. We can write it as the integral of u power 0 du. Using power rule, this is the same as u power 0 plus 1 all over 0 plus 1. And what do we have? Remember, 0 plus 1 is just u power 1 all over 1. And what is this? U. That's how we obtain u from the integral of 1. And what do we have next? Minus 2/3. And what we have here, I'm going to show you shortly, this is tan inverse of u. And then we have to say plus c, because our integral is an indefinite one. Now we have to revert to our original variable. And in order for us to get back to our original variable, I told you we're going to need it. Here it is, the connection between x and u. So where I see u, I put the square root, the positive square root of x cubed minus 1. So our final solution then is going to be as follows. Our final solution is going to be, this will be 2/3 times the square root of x cubed minus 1, positive x cubed minus 1. My marker is not very clear here, but I'll make sure that you can clearly see it there. And then we have minus 2/3. This is 1 times tan inverse of the same expression, which is square root of x cubed minus 1, and then we have to say plus c. Now I have to write this clearly using a darker marker. This one, maybe it will do a better job. So we're saying 2/3 square root of x cubed minus 1 minus 2/3 tan inverse of the square root of x cubed minus 1, and then plus your constant c. Now I want to explain how you obtain this from this one very quickly as follows. We're looking at the integral of 1 over u squared plus 1 giving us tan inverse of u, and we said that u is actually this expression here. So as far as our integral is concerned, this is the final solution. But I just want to show you how we obtain this from this one here. So let me put this one in a rectangular box just to say that we are done with our integral. Now just for clarity, how we obtain that from that. I hope to be very fast indeed to be able to do that. Let me move this page here. Right, so basically I'm saying the integral of 1 over u squared plus 1 du. We use trig substitution. 1 plus u squared plus 1. It should remind you of this expression here. When we talk about trig identities, it should remind you of sine squared theta plus cos squared theta being equal to 1. So if you divide throughout by cos squared theta, you're assuming cos squared theta is not equal to 0, you're going to have sine squared theta over cos squared theta plus cos squared theta over cos squared theta equals 1 over cos squared theta. Remember I said cos squared theta is not equal to 0. That's the assumption. This is tan squared theta plus this is 1, and that is 1 is actually sec squared theta. So now notice something. This here resembles what you see in the denominator there. So whenever you see x squared plus 1 or u squared plus 1, tan substitution. So now we're going to say let tan theta be equal to u. Chain rule differentiation on both sides, we're going to have sec squared theta d theta equals du. Remember, derivative of tan is equal to sec squared. Now from here we can actually say, okay, so from here what we have is the integral of 1 over tan squared theta plus 1, and then times what is du? It is sec squared theta d theta. But remember, I told you tan squared theta plus 1 is actually what? Sec squared. So we put sec squared down here. So this is the integral of 1 over sec squared theta times sec squared theta d theta. You agree with me? These cancel. It's the integral of 1 d theta, and I showed you earlier on that this is actually theta. The integral of 1 with respect to theta is theta. But what is theta? From here, you can see that theta is actually tan inverse of u, or arctan of u. So this is tan inverse of u. So where are we coming from? We're coming from that, and our final solution is this. This is why over here, that should give you that. All right, so this is how you evaluate this integral here, where we're coming from. Let me just remind you where our original integral is. Hopefully I can get it here. Here it is. There is our original integral that we have been evaluating. And what is our final solution? Well, here is our final solution. There it is over here. That's the final solution. Some people would prefer to factorize this and take out 2/3 as a common factor, but it makes no difference. You can leave it the way it is. It's just fine. All right, I hope you found that interesting. I'll see you in the next one.